All right, so today we are going to start our new unit on extending data structures. Our last unit was the creating and altering data structures unit. So we learned mostly about lists and how they work and how to do stuff with them. So in this unit, we're going to be doing some more complex things with lists, and we're going to learn some other types of data structures as well. So today, the module we're learning about is the two-dimensional lists module. So let's get started. So let's talk about what a 2D list actually is. When I say I'm making a 2D list, what I really mean is that I'm making a list where every element in that list is another list. Here's how making one looks. I make my variable, I say it equals a set of square brackets with something inside. I have my element number 1, that's going to be a list. Element 2, also a list. Element 3, also a list. I have 3 elements, all of them are lists within one overall list. I can also write it out in my code in a way that looks a little bit more like an actual grid with each of those separate lists on their own line. And that lets me see kind of the horizontal and vertical aspect of this 2D list. It more looks like an actual grid. So there's a couple of properties that you're going to need to know about 2D lists that are special about them. First, each of the sublists within the overall 2D list, those are called our rows. It is the common name for them. Those are the rows of the grid. Each element in those rows has an index, and that index is going to be its column index. So we have rows that are represented by those lists, and the columns, those aren't tied together by a list in any way, but all of the values in a column have that same column index. Lastly, the number of elements in each row has to be the same. You can't have any one row be longer or shorter than another row. Otherwise, your grid loses its nice rectangular shape and becomes kind of misshapen and wrong. So we want to make sure all of our rows have the same number of elements. And we can access a single element within our 2D list by knowing its index in both the row and column. Accessing a 2D list is going to be just about the same as accessing any other kind of list that we've created so far. So if I want to print my grid at index 0, my grid is the same list we had. We have the list 1, 2, 3, the list 4, 5, 6, and the list 7, 8, 9, all within my big list. Index 0 within my grid is going to be that list 1, 2, 3. So I print it, I get the list 1, 2, 3. And I'm also allowed to slice my 2D list because that is a list. Any list can be sliced. So if I slice from 0 to 2, we're not going to include 2. So we're going to have the lists 1, 2, 3, and 4, 5, 6 still in another list because a chunk of a list is going to be yet another list. So we get left with the list of the list 1, 2, 3, and the list 4, 5, 6, all as one big list. If I want to grab a single element out of a 2D list, I need to supply both the row and the column index for that value. And those two indices are always going to be in that order. First you say the row, then you say the column, and you're going to have each of those values within their own set of square brackets, as you can see here. So if I want to grab from my grid row number 2, I have 0, 1, 2. That's the 7, 8, 9 row. From that row, I'm going to grab column number 2, 0, 1, 2. That's going to give me the value 9. If I want to grab from my row number 1, that's going to be my 4, 5, 6 row. And that row is a list, so I'm allowed to slice that list. So if I want to slice from index 1 until the end, it's going to start at index 1 in that list. It's going to be 5 until the end. So it's going to be 5, 6. It's going to be that whole end of the list. All right, now that we know how to access a 2D list, let's talk about creating them. So there's a few ways to go about this. The first one you've already seen. Like we saw on these other slides, you can just pre-fill a list with values. We can also append lists to the end of an empty list and build a 2D list while our program is running. So if I say my grid is an empty list, open and close those square brackets, I can make my 3 rows, each one being its own list. I can say row 1 is the list A, B, C, row 2 is the list 1, 2, 3, and row 3 is the list do, re, mi. I have 3 separate lists, and then I can append each of those rows into my overall grid, thus giving me a list of lists, because append is going to add 1 value to the end of the my grid variable. It's going to add 1 value, that value being the whole list. So I get 1 list, 2 list, 3 list appended to the end of my grid, thus giving me that 3 by 3 grid size. As our lists get bigger and bigger, though, it becomes increasingly cumbersome to just create all of those rows manually. Fortunately, we can use for loops to make it super easy to make a large 2D list. I can create my grid as an empty list, and I can make a loop to make each row manually, or not manually. So I can say for I in range 3, so I'm going to have 3 rows, I'm going to make a blank row, and then I'm going to have another for loop. For j in range 3, so I'm going to have 3 columns. This is going to make a 3 by 3 grid. If I increase those numbers, my grid is going to increase in size. So inside of that j for loop, I can say row.append. I'm going to add a new value to that row. I'm going to add I plus j. Both I and j start at 0, so my first value in there is going to be 0. J is going to increase to 1. 0 plus 1 is 1. And then j is going to increase again to 2. 0 plus 2 is 2. So then our row is complete. That loop is finished. So we're going to go down to the next line, mygrid.append row. We're going to take that list that we just made. We're going to add it to the grid. So our grid now has 1 row in it. Our loop is going to start the next one. I is going to go from 0 to 1, and row is going to get blanked out. Then we can say for j in range 3 again, this is our second time doing this second loop. We're going to append I plus j. I is now 1, j starts back at 0, 1 and 0 is 1. And that one keeps looping. We get 1, 2, 3. We're going to append that row to our grid. Our row is going to get blanked out. I is now 2, j starts at 0. We get 2, 3, 4. We append that row, and then we have our final grid. There we go. We have a 2 by 2 list. Not a 2 by 2 list. We have a 3 by 3 list. 2-dimensional grid. If we want to make a list where every element has the same value, we can use the multiplying or asterisk operator like this. It works very similarly to when we multiply a string by an integer. So we say my list equals, and then we create square brackets and have some value inside, and we're going to multiply by an integer, and that's going to fill that list with that integer number of copies of whatever value is inside the list we said. So our resulting list from this operation is going to have 8 ones in it. So we have 1, 2, 3, 4, 5, 6, 7, 8 ones in that list. So if we append this operation in a loop, we can make rows that way and then pre-fill our list, our 2D list, to be the size that we want just that way. All right, so if we want to loop over a 2D list, it's almost identical to looping over a regular list. You can use either style of for loop to look at each row, and then when you're inside of that for loop, you can look at each element within that row with a second for loop. So if I have for I in range the len of my grid, the length of my grid is going to be the number of rows that I have. Within that loop, I can say for j in range, the length of my first row, and I can use the first row's length because all of my rows should have the same length. If you want to, just in case, use I instead of 0 here, that's perfectly fine, but I like to use 0, so I'm going to be using 0. And then if I want to actually access my 2D list at the index I'm currently looking at, I can print my grid at index I at the row value and then the column value, which is stored in J. And that will print every single value, one row or one element at a time, row by row, everything inside of my list. And I can use the other style of for loop as well. I can say for each element in my list, do something. So I can say for each of the rows in my 2D list, and then for that row, I can say for each element in that row, because row is going to be a list, I can print that individual element. So if I don't care about the indices of what I'm working with, I could always just do the second style of for loop with my 2D list.